Alright, so let's first start with our critical points. Make these a little bit bigger. Okay, so sine goes from 0 to 2 pi. So pi x all the way up to 2 pi. So I want to solve for x, so divide everybody by pi. Okay, so what that gives me is 0 less than x less than 2. So when I set up my number line, I'm going to go from 0 to 2, and then I just start halving things. So halfway is 1, halfway is a half, halfway there is 3 halves. And then the other thing I need to look at is I've got a vertical translation of 3, so up 3 is my new middle. But then my amplitude is 4, so it's going to go up and down 4 from that. So if 3 is the middle, that means the highest is 7, and the lowest is actually -1. Okay, so then I want to follow the sine pattern. Sine starts in the middle, up to the top, middle, down to the bottom, back to the middle. And then draw a smooth, continuous curve. And so there's our sine graph. In the next graph, okay, same trick. I want to start by looking at the parent function. So 0 to x minus pi less than 2 pi. Okay, so I'm going to add pi to both sides. So pi is less than 2x is less than 3 pi. And divide everybody by 2. So I get pi halves less than x less than 3 pi halves. Okay, so in this case, I've got to put a little more work in getting my critical values. So I'm going to start here at pi halves. I'm going to go 3 pi halves. Now, what's in the middle of those two? Well, halfway between 1 half and 3 halves is 1. So we got pi in the middle. And then the other two middles might not be so obvious. So maybe we want to do a little bit more math to figure that out. So if I take pi plus pi halves, divide that by 2, that'd be 2 pi halves plus pi halves, all divided by 2. Which is 3 pi fourths. Okay, so 3 pi fourths there. So I probably think this other one is going to be a fourth of some type, but let's add that up. So 3 pi halves plus pi, but let's go ahead and leave it as 2 pi halves all over 2. So I get 5 pi fourths. So yeah, it is a fourth of some type. Okay, so those are my critical points. Then I've got a vertical translation of 2. So here's 0, and I'm going to go up to 2. And there's my new middle. And I want to go up and down 3 from it. So I'm going to go all the way up to 5 and down to -1. And then we got to remember our pattern. It's cosine. So cosine normally starts at the top, but because we got a negative out in front of that 3, it's actually going to start down below. So it's going to be bottom, middle, top, middle, bottom, and then sketch my curve in. Okay, tangent, we have to remember tangent is the one that starts its graph at -pi halves. Let's see, x over 2 and then pi halves. Okay, so here I want to multiply everybody by 2. And that'll give me -pi is less than x is less than pi. So when I sketch it, I'm going to go from -pi to pi, and in the middle would be 0. Tangent has asymptotes at the ends, and then tangent actually starts at the bottom and ends at the top. So there's our curve for that. All right, cosecant. Cosecant, we're going to pretend for just a half second, is actually cosine. And then we're going to set it up based off of cosine's pattern. So 2x minus pi is less than 2 pi. We add, hey, these numbers look rather familiar. So we end up with pi less than 2x less than 3 pi. Divide, so we get pi halves less than pi less than 3 pi halves. So we come over here, pi halves, 3 pi halves. Halfway is pi, halfway there is 3 pi fourths, and 5 pi fourths, because we just used those numbers. Let's see, no vertical translation. Now the 3 does tell me that it goes up 3 and down -3. And then in the cosine pattern, I want to start at the top, the middle, bottom, the middle, and the top. Okay, so then here's where secant is different. So with secant, anytime I crossed a middle, I want to put an asymptote there. And then there's the sort of half parabolas on the two ends, and then the full looking curve in the middle. So there's our secant graph. All right, number 17, we are given, given cosine theta is 3/4, sketch a right triangle. It has an acute angle of that. Use definitions to find the other 5 trig ratios. So this isn't a calculator skill. This is come in, draw a right triangle, and set it up so that it has a cosine of 3/4. Well, 3/4 cosine is adjacent over hypotenuse. So we're going to set that equal to 3, that equal to 4. On the other side would be 4 squared minus 3 squared. So 16 minus 9, so that's actually square root of 7. So then from here I want to go in and find all of my trig ones. And let's see, cosine, sine theta, tangent theta. Let's get those 3 first, and then we'll go find the reciprocals. So sine theta would be square root 7 over 4. Tangent is opposite over adjacent, so that's square root of 7 over 3. And then we want to come back in and find all of the reciprocals now that we can kind of see a little bit better what's going on here. Well, reciprocal 3/4 is 4/3. Cosecant would be 4 over the square root of 7, which if we rationalize, we should get 4 square root 7 over 7. Tangent would be 3 over the square root of 7, which is 3 square root 7 over 7 for that one. Number 18, we are asked to solve the triangle. Well, let's see, so that means we got to find angle B, and then I need to find side A and side C. We're actually given that it's a right triangle, so that actually speeds up a lot of this math. So because it's a right triangle, then I can take the 40 plus the 90, hopefully get 50 out of that. So angle B is 50 degrees. Because it's a right triangle, then we can actually go with our right triangle trig functions, so sine, cosine, and tangent. So let's see. There's A, and related to B, that'd be tangent. So tangent of 40 degrees equals A over 6. So I actually want to multiply that out. I will caution you, double check that your calculator is in degree mode before you do this. Sometimes students get very excited. They got an easy problem and then they don't check the mode and end up getting it wrong. Okay, so A in this case is 5.03. All right, then there's C, and so C with respect to B is actually cosine. So cosine of 40 degrees is B 6 over C. And so I actually want to do 6 over the cosine of 40 to get C. So I want to divide those two. So 6 divided by cosine 40. And I get 7.83. Okay. All right, number 19, tricky part here is to recognize what identity we're supposed to use. So in this case, it's cos, sine, sine. So that is one of our cosine ones. It's actually difference of cosine, so 135 minus 15, which hopefully is, oh, hopefully I didn't, oh, you know what, yeah, it's 120. Okay, so then we want to think, well, 120 is in the second quadrant. It's got a reference of 60, so I want to think about what the cosine value of that is, and hopefully we get that it's -1/2, hopefully. Second one here, sine of 90 plus x, that's the sum of sine, so it's sine of 90 cosine of x plus cosine of 90 sine of x. Okay, so then we got to think back to our unit circle values. So sine of 90 would be 1. Cosine of 90 is 0. So I just end up with cosine x. That's what that simplifies down to. All right, 2 cosine squared 15 degrees minus 1. That is actually straight out of the textbook for double cosine. So it's cosine of 2 times the 15. So that's cosine of 30. And cosine of 30 would be square root 3 over 2. All right, and the other one, think about what does that remind us of, and it almost looks like the double angle identity, but it's missing a 2 out front. So what we do is we do a little manipulation. So I say I'm going to multiply by 2, but I'm also going to multiply by 1/2 at the same time. Now that piece, so 1/2, 2 sine cosine is actually sine of 2 times the 22.5. Now, again, I want to clarify, I didn't factor or distribute the 2 in. That's not what happened. This is actually just the definition of the double angle of sine. So it's 1/2 times the sine of 45 degrees, which is 1/2 times square root 2 over 2. So square root 2 over 4. All right, in number 22, I want to remind myself of what the general form for a parabola is. So in this case, it would be x minus h squared 4p y minus k, where h and k are the vertex. Okay, so it's almost in that form, except I would like to know what p is. So 4 times something, which is 2, times y plus 2. Okay, so then the vertex would be at 4 comma negative 2. Okay, so as I sketch this, 1, 2, 3, 4, 1, 2 down there, the fact that it's x squared means it's an up-down 1, and the fact that that focal length is positive means it's an up 1. So if I go up 2 from 4, negative 2, that puts me at 4, 0, so that's my focus. And then if I go down 2, so y equals negative 4, we'll just pretend that that's a negative 4. Sure, that's a little wide there. And then let's see, lattice rectum. So if I go from 0, so it's a distance of 4. So if I go 4 sideways, so 0, 0 for one point, and 8, 0 for the other. Those 2 points are on the lattice rectum. And then I can attempt to draw a smooth curve between those points. That is an attempt, by the way.